It's buffering, and we're live.
Hi, everyone.
Yeah, my name is Mark. I'm a coach at Udacity, and
I'm Andy. I'm helping guide you through this nano degree.
awesome. Yeah, so today we'll be having a live coding session with Andy, specifically about Python. So last week we had a coding session with Andy about HTML and CSS, right?
Yep.
And now we are diving into the world of Python programming. Now, before we start having Andy do our coding session, I want to have a little announcement for especially for Windows users who are having trouble submitting their projects in our grading portal. There was an error for Windows users. They could not submit their zip file for grading. That has been resolved. So our engineers just fixed it today. They're pushing the code live to our production servers right now. So at the end of today, please resubmit your file again, and it should work. Now, if it does not work, please let us know on the forums or email us at introprogramming-support@udacity.com. Once again, it's introprogramming-support@udacity.com. Okay, great. Now I'm just going to hand it over to Annie.
All right. So the purpose of this live coding session is to walk through how I think about solving a large problem that involves programming. I've heard a lot of feedback in the forums, especially people who have made it a decent ways through the second course, that you can read the code that somebody else has written. You can see the solution, sort of get what it does, but have time coming up with an answer on your own. And that's very normal. That is a stage of learning to program that you go through. This stuff takes a lot of practice, and it's going to take a lot of time before you get to the point where you can create problems or create solutions to big problems on your own in any reasonable amount of time. But it comes to practice. And one way to get that practice is to see how other people go about solving those problems. And so that's what we're going to do today. If you're in the most recent cohort, the one that began in March, you're probably still thinking about HTML, and that's fine. This may not be as useful for you as it is for people who have already started working on Python. It may be a little useful seeing how I think about decomposing a big problem into smaller pieces, but it's going to be hard to follow along. So keep that in mind. Next week we'll do something a little more HTML friendly, but for now we're going to do this in Python. And so let me share my screen so we can.
Let me know when you share so I could put you online. Let's see. All right, you're sharing your screen. So.
All right. So the problem I want to solve today is writing something that would check to see if a Sudoku solution is correct. I chose this because you can represent a Sudoku puzzle pretty easily as a list of lists, and I know that depending on how far in the nano degree you are so far, you know what lists are and you have some familiarity with that. If you don't, that's okay. Follow along or come back to this video later. But Sudoku, it's a puzzle. You get a grid that's partially filled out with numbers, and the goal, you can see the red letters, numbers here, is to fill it out in such a way that as you go across all of the rows, you use the numbers 1 through 9. As you go down all the columns, you use the numbers 1 through 9. So in this column, you'll see 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then likewise with all these, you see these 9 squares. Square 0, square 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I counted from 0. That's me being a Python person. But you can tell that each of these squares also uses the numbers 1 through 9. So I just phrased to you how to check and see if a solution is correct in Sudoku, right? Check the rows, check the columns, check the squares. But how do we do that in programming? How do we begin to approach this giant problem? So let me pull up Sublime Text. And feel free to ask questions along the way. Mark's keeping an eye on what you guys are saying, so if there's any questions, I'll try and get to them. So I hope you can see this.
Yeah, it looks pretty good.
It's good?
Yeah.
So I wrote down 3 steps that I like to follow when solving a problem. First, I want to understand the problem. And I'm going to think of understanding it in terms of inputs and outputs. This isn't how we think as humans, but it's how we think as programmers, because that's how computers think. Then I'm going to plan a solution, and I'll show you how to go about planning a solution. Then I'm going to fill it out, and I said fill it out, and you'll see what I mean by that as we go. So first, let's understand the Sudoku problem. What are the inputs? I want to represent a Sudoku puzzle as a grid like this. And I call this invalid grid because this doesn't meet some of the specifications of Sudoku. You can tell this grid is a list. So here is the outermost brackets to say that this is a list. And then inside that list, I have 9 lists. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can probably guess how this is supposed to represent that Sudoku board. I didn't represent any squares in here yet, but that was a choice. We'll get to that later. And this code down here, I just found a valid Sudoku puzzle. So this solution actually checks out the rows add up, or the rows have the correct number of numbers, the columns do too, and same with the squares. All right. So I understand the inputs. In the case of the Sudoku puzzle, I'll say it's a list of lists. And maybe I would give an example, but I did that down here in invalid grid. And then the outputs. Well, all I want to know is if a given input is a good solution to a Sudoku or if it's not. So true or false. That's all it's going to output. I might have some print statements along the way to help me as I think about, debugging this thing, but we'll get to that in a second. Now let's plan a solution. And since I don't have paper, I'm going to opt for this pretend code version. Let me show you what that means. So I'm going to write code, and I'm going to pretend like I have access to functions that I haven't even written yet. And that turns out, for me, to be a really helpful way to approach these big problems. Instead of diving into the details first, I'm going to make a function. Let me get you some more room there. I'm going to call it check Sudoku. It's going to take as input a Sudoku grid. Now, what do I want this check Sudoku function to do? Let's see. Well, I want it to return true if it's a valid Sudoku. So how do I tell if it's a valid Sudoku? Well, we talked about earlier, we need to check the rows, the columns, and the squares. So I'm going to write this. If check rows of Sudoku grid, I'm going to write equals true. You don't actually need that, but I'm going to write that to make it a little more clear. Then I'm going to print just to let me keep track of what's going on, that the rows look good. Then I'm going to check the columns. If check columns of the Sudoku grid is true. I'm also going to print columns look good. And then I'm going to check the squares. There are other ways we could have written what I'm writing here. We could have done this in a single line. I could have said if check rows and check columns and check squares. But I like this because it's going to slowly let us see if the rows are good, the columns, and so on. Now I can just return true because now we've made it all the way. This is a valid Sudoku grid. We've checked the squares, we checked the columns, we checked the rows. But you're probably saying, but you don't have those functions yet. You haven't written check rows, you haven't written check columns, and that's absolutely true. And if I try to run this function now, print check Sudoku of, let's say, the valid grid from up above. Actually, I'm going to write these in all caps. It's a good practice if you just have variables hanging out that aren't inside of a function to write them as all caps. Okay, so let's see what's going to happen. I'm going to hit on my Mac Command B to run this. I think it would be probably Control or Alt B on the Windows machine. Oops.
Right, yeah, you see that low.
And then down here is my output.
Yeah.
And how am I going to read this? Okay, let's read through this from the very top. Traceback, most recent call last. So I actually want to go the other way. I'm going to start at the bottom. I usually start at the bottom of these things. So name error. Global name check rows is not defined. So that means that I called this function check Sudoku. It tried to call this, but of course it wasn't defined. And I should have known that was going to happen. So I did know that was going to happen. But that's the error. That's okay. Let's define it. In this system of gradually fleshing out your solution, you start from the biggest picture. Check Sudoku, right? It just means I'm going to check the rows, the columns, and the squares. And then, as your code doesn't run, you just keep refining it until it looks like it's working. So I'm going to write def check rows of. I'm just going to actually make this grid. I just want it to be clear which variables are which. It can get confusing when you have similar words and the same parameters and all that. So check rows. So this Sudoku grid is a list of lists. So I can use a for loop to go through the rows of that list. So for row and grid. And to show you what that actually does, let's just print out each of those rows first. And I'm going to comment this out. And we're just going to do check rows of that valid grid. So you can see for row and grid, it prints the row, and it prints each one on a new line. That's why you don't see those the brackets at the very beginning and the very end, because it's just printing the things inside of that grid, which are the elements, the rows. Okay, so now I know how to get access to each of those rows. I'm going to call each of these numbers a cell, because it seems to make sense. We have rows, we have columns, and each of these little squares, the value inside we'll call a cell. So I'm going to do another for loop. I'm going to do for cell in row. And just to remind you what this is going to print, let's just look at exactly what this does. And this is kind of a mess, but you can see 4, 3, 5, 2, 6, 9. It's just printing out each individual letter or number. Sorry. Okay, so that's how we iterate through our grid. Now, what do I actually want to do? I'm checking the row. I want to check and make sure that each row is valid. So if, let's say, is valid row, and again, I'm making up a function of row of. So what do I want to do, actually? So this is where you have to stop and think. I want to go through all of these rows, and if one of them is bad, then the whole thing is bad, and I want to return false. So actually, I want to do if is valid row. If any of these are not valid, if any of them are false, I'm going to return false. This is no good. And only when I've gone through this whole for loop and confirmed that none of them are false, I haven't returned anything yet, only then will I make it down here and be able to actually return true. And if I ran check rows here, I'm getting the is valid row is not defined as expected. So let's just write that. Def is valid row. And I'm going to make, I have my desired thing that I made up here. Well, that's not what I want, sorry. So required numbers. These are the numbers that I need to see in each row. I need to see 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a clever, I could have done that using something called Python's range function, but I'm going to just write it out for you guys. And let's see, what do I want to do? Let's do for number in required numbers. So that's going to go through all those numbers. 1, 2, 3, 4, 5. If that number is not in the row, that's bad. That's not a good row. So we're going to return false. And only if we've gone through and verified that it's all those numbers are, can we return true. And look, now we've gotten somewhere. We haven't written any pretend anything that's fake. So in theory, if we check the rows of something, of a grid, like valid grid, maybe it'll return true if we haven't messed up. Oh, let's do print check rows.
It's true.
Oh, cool.
Oh.
That worked. So,
wow.
So the valid grid has valid rows at least. We haven't checked its columns. Let's actually look at the invalid grid.
Yeah, let's check that.
And that's true too. But that's okay. That doesn't mean our code is bad, because if you look at the invalid grid, I just made a bunch of 1, 2, 3, 4, 5, 6, 7, 8, 9. So those rows actually are all good. So that's why we have the column check, because that's not enough for our Sudoku. Okay, cool. So let's zoom out for a second. Let me pull this down. There's this thing you can do in Sublime. You click these little triangles, and it just collapses everything. So check rows can collapse down. Check Sudoku gets collapsed down. I can collapse that, collapse that. Okay. So let's go back to check Sudoku. Let's open that. So we've gotten check rows figured out. Now we need to do check columns. So let's define that function. And a meta point, I've collapsed these rows, these functions. I can open them up again by clicking the green arrow, or that little arrow next to it. I like leaving them collapsed. It's just less for me to have to look at and think about, keep my mind, my workspace clean. So check columns. Wow, how am I going to check columns? Rows were a little easier because the lists themselves were in rows.
That's a very, very good point. Yeah.
So
yeah,
this is not as easy. So one thing I could do is I could say, well, I know I want to check index 0 of every row.
Yeah.
I want to check index 1. I want to check index 2.
That's a good systematic way of thinking.
Okay. Right? Okay. So so let's see. I'm going to do for index in. And this is where I'm actually going to use this range function, range 9. And let me show you what range 9 prints out. Sorry, let me do that right up here. So I just ran this code. Oops. And up at, oh, sorry. That's not going to work. Yeah. So indentation error. This happens all the time in Python. Yeah. I love Python. I love other languages use these curly braces everywhere and brackets and parentheses, and it's easy to forget those too. But Python, it has a problem. It's easy to mess up your indentation. So let's go to line 61 and see what the problem is. So here's 61. I wrote this for loop, but I don't have anything. Let me just comment this whole thing out. Let me get rid of this as well. Oops. Okay. So now let's try that again. Okay, so range 9 generates all the numbers, a list of all the numbers between 0 and just up to 9. One less, so up to 8. Mm-hmm. Okay, so let's do our check columns. Where did check columns go? Here. So what do I want to do? I'm going to go through all the, so index will be 0 and then 1 and then 2. And what I really want is when index is 0, I want to check all of these down at index 0. Then I want to check all the ones at index 1. Okay, so I could do this with another pretend function, but I think I'm just going to write this one. So let's see. So I'm going to, up above here, I'm going to make an empty list. I'm going to call it columns. And each of these, I'm going to make a new column. So I'm going to go over every row in the grid. And first I'm going to make a new empty column. And for every row in the grid, I'm going to get whatever the value is at that index, so either 0 or 1 or 2 or whatever. And I'm going to add it to my new column. So that's going to be row of index. Now the code we have here, this line of code, the only reason I could write this so quickly, and I'm not even sure it's going to work, but I think it will, but the only reason I can write this so quickly is because I've written lines similar to this 100 times before. I've thought of going through lists of lists and keeping track of an index, and if this looks very foreign, or how would you ever come up with it? The answer is just practice. It's a new language. Python is a new language for you, and like anything, fluency comes with practice. But here we go. So I'm going to add the right entry, that's row at index, to my new column. And after I've gone through every row in the grid, I'm going to add my new column. I'm going to add my new column to these columns. Because now what I have is these, let's just print columns so we can show you what we've done here, if this works. So I'm going to take this invalid grid, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on, and I'm going to see what happens when I do check columns on that. It's not actually checking the columns yet. It's not complete, but let's see. Any guesses on what it's going to return?
I guess, yeah.
Okay, let me try this one more time. Actually, let's do four column.
Yeah.
Because it was giving me this whole list.
Yeah.
I just want to print out each column one time.
Each column.
And I'm going to make this return.
There we go. You basically converted all the columns into.
Wait, let me get rid of this line. That's confusing.
Where's that line?
That's the range 9.
Oh, okay.
So see what we had before? We had ones going all the way down the side, and now we have ones going all the way along the top. Now the reason I did this is because I know how to check rows. I've already written the function. So now I'm actually not going to return columns. I'm just going to return check rows on those columns because I know how to do that. So let's see what happens when we check the Sudoku on our valid grid at this point. And let me get rid of this. Okay, rows look good. The columns look good.
Okay.
So it looks like this check columns function. And I should let you all know, I wrote this code before we did this. And there were a lot of bugs along the way. I do not want you to think this is how the coding process works. This took me a long time to figure it out, and I'm just showing you in a shortened form how I thought about it.
Yeah. So
normally there'd be a ton of errors. There were a ton of errors. That's how it actually goes. So okay, the rows look good and the columns look good. So let's zoom out again. I'm a big fan of zooming out. All right, we've got a function called check Sudoku. It takes as input a grid that looks something like this, a list of lists. And it goes through. First, it checks the rows to make sure that they each have the values 1 through 9. Then it goes through and it checks the columns to make sure they each have the values 1 through 9. Then it goes through and, well, soon it will go through and check the squares. We can see in our traceback error, all the way down here, global name check squares is not defined. Check squares is not defined. Right, I haven't defined it yet. So it looks like we know what we have to do next. Let me just put these all next to each other so we can see them on one screen. This is useless. I don't know why this is floating around. So you can see what we mean by filling out our solution, by the way. So this is us planning / filling it out. We're writing code hoping that we have functions later, but we don't. So this check squares function, I'm going to tell you in advance, took me a long time to figure out. So if I have a grid, and I'm going to call this a grid that's 9 by 9. And the reason I'm going to do that is to distinguish this Sudoku grid from the grid of the squares, which are 3 by 3. So how am I going to check the squares? So let's see. Let's go back to what our data looks like. You know, there's a few ways we could do this. I think what I want to do is I want to first get this in square form. And what is square form going to look like? Well, that's a good question. I think I'm going to think of this as a row. Here we're going to have like a row of 3 squares. So the biggest list is going to contain 3 rows with these 3, they each have these 3 squares. This is going to be the first one, that would be the second one, and this would be the third one. Then each of those 3 rows are going to have 3 squares. So this one's going to have the square that's all in here. Can I do, oops. I don't know how to highlight that way, but it's going to have this, this, and this. And then each of the squares are going to have rows, and each of those rows are going to have entries. So that's going to be like a list of lists of lists of lists. If you didn't want to do it that way, there's other ways to do it. This is the way I'm going to do it. You can go as deep as you want. You can have as many lists inside of lists as you want, and I kind of like this approach. So how are we going to do it? Geez, so we said that this full grid is made of rows of 3 squares. So for row of 3 squares, remember each of those squares is 3 by 3. In the oh, sorry, the grid is just the thing. Oh man, I have to make squares first, huh? So I'm going to just try and convert this grid, this 9 by 9 grid, into a row of squares. Then for each of those rows, I'm going to have 3 squares in each of those rows. So I'm going to iterate over those squares. For square in and now I'm going to check that square. So that square should be a 3 by 3 grid. Basically, it should look similar to this. Let me just give you one example. Sample square would be something like 1, 2, 3. 4, 5, 6, 7, 8, 9. And that would, as just a square, that would be valid. So that's what one of these squares would look like. So I'm going to do that thing where I pretend I have a function. So I'm going to do if check square. Notice that's just a single square. There's no s on the end here, so this is a different function. And I'm just going to refer to this square. It's the same one. So if that's false, it doesn't matter. One square is bad, the whole puzzle's bad. I can return false. And if I've gotten through every square in every row, only then can I return true. Okay, this is a lot. And I'm not going to keep going with this because I know this is hard to follow at this point. The reason I'm able to do this quickly is because, like I said, I kind of thought about this already. But let me show you what my solution code looked like. Okay, that looks similar. Check rows. So this was actually, I had to change my solution because I'm not really a fan of Sudoku. So I actually earlier thought that the only requirement was that the sum, the total of each row, had to be 1 plus 2 plus 3 plus 4 plus... And that's not correct. It actually needs one of each. So
it needs one of each, yeah.
So I had to modify this a little bit. But let's go with this. It doesn't change the idea too much. Check columns looks a little different. You can see I've got these print statements. Those are there because of I had to debug this. I didn't put them in while I was solving it from memory because I didn't need them. I remembered what the solution was, and I had just gone through all these problems an hour ago. But these were here to show me like where in the code things were failing. It wasn't working, and I didn't know why, and I needed those there. So my check squares function, okay, so I call it get squares instead of make squares. But similar sort of thing. The check square function, it goes through each row in that 3 by 3. Well, again, remember, this is me thinking. It just had to add up to some desired sum, so this would require some modification.
Right.
Else return false. And
like for those of you who are it's a little bit confusing, we'll be sure to post this.
Yeah, we're gonna definitely post.
We'll post this code along with like comments and like the way that we're thinking. So don't worry if you're trying to feverishly understand every line of code.
Yeah.
Just make sure that you're understanding the bigger concept of like here we are like.
This is the bigger concept.
This is the bigger concept, yeah.
The steps for solving a problem.
Basically, that's the main thing that we want you to get away from this exercise.
Yeah.
Really. So, like Andy, do you have anything else to show for this type of code?
I think that's all. Maybe I'm going to stop sharing my screen so I can actually.
Okay, we are broadcasting live on this account right now. Okay, great. Yeah. So, we will for sure post this code so you could like follow along the thinking process. That's the most important thing. And the main thing is really succinctly we break things down,
Mm-hmm.
right, Andy?
Yep. And we have a little more time. Can I
Go ahead.
quickly show you how I would apply this
Yeah,
to...
you need to screen share.
Oh,
okay,
yeah.
hold it. Your screen share already. Okay, we're good.
Okay. So if you've gotten to stage 2 to work session 5, let's just do this from scratch. This applies so well to this last problem, where what was the problem?
This generic concept. HTML.
Let me reset this. Okay. So this is where I wanted to, I'm just going to get rid of all this. I want to write a function called make HTML from any concepts, because what I wanted to do was I wanted to stop having to copy and paste my divs. I want to be able to specify the concepts I want in my notes in one place and just modify that instead of having to keep modifying my actual HTML file by copy and pasting, which is error prone. So for example, let's say I have Python. So I'm just going to keep these very minimal for illustration. And then maybe I'd have another entry that was HTML. I'll do stands for hypertext markup language. Okay. So this is my choice of data structure, it's called, for how I want to represent concepts. Oops. Each concept is a list. Each list has a title in the beginning. Oh, sorry. Oh, no. Has a title and a description. Title, description. And so applying the same thought process to solving sort of this problem, I would say, like, all right, let's do what was it called? Make HTML from any comments. Many concepts. And that's going to take concept list. I'm just calling it something different to distinguish it from this, even though I'm eventually going to call this function with this argument. This can be tricky. There's a lot of stuff floating around, but I'm going to just call it concept list for now. Okay, so what do I want to do? So first, I want to iterate over this big list that's in green right now. So I'm going to do for concept in concept list. Oh, I'm making HTML and I want that as a string, so actually I have to remember I'm going to first start with an empty string, and I'm going to just keep adding to that. So let's see, what am I going to add? I'm going to add HTML is going to equal whatever the previous HTML was, which right now is this, but remember, it's not always going to be this. As we loop through, we're going to be making this bigger and bigger. So I'm going to call this function make HTML for concept. I forget what it was actually called. And that's going to take a single concept as a argument. And remember, a single concept is a list like that. And then I'm going to return the HTML. So that looks pretty simple, right? This code is nice and readable. I know I have to go and find or create and make HTML for concept, but I can read through this and sort of get what's going on. And somebody else could too, even if that someone else is you in a week, because it can often be hard to read your code a week later. Now I need to make this function.
Yeah, just want to like do a little commentary as Andy's coding. It's like Andy's actually breaking things down, and he's actually doing this exercise called Sudoku, and he's actually thinking and writing down as he types, and he's actually breaking things down and actually creating these functions and name them in a way that makes sense in the regular English language.
Thanks for doing that, because I have a lot of just boilerplate code to write. So
yeah.
If you can keep riffing, that's great.
Yeah, exactly. So basically, like, really, it's a really good way for you to start thinking, like, okay, how can I transfer what's in my head to what's on paper, and then what's on paper to something that the computer program could actually go and understand. So the first step is to think about, again, like, understand the bigger issue, like, what is the question? What is it that we're trying to do? What are the inputs that we're getting, and what are the outputs that we're supposed to make? Really, if you think of it, it's just really like you are like basically the machine, right? You you program the machine to take some sort of input, some sort of raw input. It does its magic, and then it outputs the thing that you want, the string or some sort of result that you want. So it's good to really just sit down and think back and zoom out, what Andy often does, and really think about, okay, what are the inputs, what are the outputs, and what are the required transformations that I need to do to transform this raw input into this output.
Thank you.
Yeah.
That's great.
You're welcome.
Okay, so I think we can go over this code a bit. So here, I define what the HTML is for a given concept. And so first I have this div that captures everything. It has a class of concept. Inside of that, there's a div with a class of concept dash title. And here, actually, I don't like this. I don't like this concept of 0. I know that if I come back to this in a week, I'm going to forget where that comes from. So let me just do title equals concept of 0.
There you go. What Andy is doing is actually a very important best practices that we define these helper variables, that instead of just accessing this array directly, we actually give it another name, basically like title, description. So we know exactly conceptually what we're trying to do.
Yeah.
So
that previous code would have worked.
Yeah.
But working isn't always enough. It's enough for the computer, but there's 2 people involved in making the code, and you are one of them, and you're going to want to do this again in a week, and it's going to be you're going to love yourself if you just were nice enough to give things very descriptive names.
Yeah. I love the fact that Andy's saying program for your future self. I often tell my students that, like, listen, you need to program for your future self and make your future self love you, like in the present.
So now, in theory, if I call this function on list of concepts as an input, it should return some HTML. So let's do that. Make HTML for any concepts. And what was that? List of concepts.
List of concepts, and we need to print this out, right? Because it's returning this.
Yes.
Yeah, let's return this.
Let's just show what happens if you don't.
Yeah.
This is one of the most fresh. Oh, there's another.
There's another global single concept is not defined.
Where was single? Okay. I called this single concept, but I was calling it in the for loop just concept.
Yeah, it's just concept.
So I'm going to just call it concept.
Okay.
Your code didn't display any output.
Yeah, there's nothing.
You don't know how many times I've looked at that output message for hours before I realized that this function was returning something, but return isn't quite the same as print. I need to print the output. And sure enough, when I do that,
nice.
It looks pretty nice.
Look at that. Auto-generated HTML code.
And now, in theory, I could just keep track of all my notes up here, and as I add new notes, so like let's say I learned something new about, let's say I learned about, tomorrow I'm going to learn about object-oriented programming. Oops. Object-oriented, this is what you'll learn in course 3. Programming is the best. Oops. And that should go. Now, instead of having to copy and paste, boom.
There we go, yeah.
I've got a nice HTML that's already properly formatted.
Awesome.
That's the value of avoiding repetition.
Awesome. We're back to video camera. Hopefully everyone saw some really good frameworks, some true programming way of thinking. We have a couple of questions.
Oh yeah.
Yeah, we have a couple of minutes, like 7 minutes left. So the first one that was most highly upvoted is, I'm late coming to office hours. Can you tell me where can I get the recording for this ones and also the ones in the past? So basically, after this office hours has been is finished, Google will actually automatically record this video. So what you need to do is just after we end this session, go back to the same page, refresh your page, and then you can actually start start playing at the beginning. So all office hour sessions will be on the Google Events site as well as in the discussion forum. So after every office hours, we go into the discussion forums and actually post a link to the specific office hour sessions as well as links to the code that Andy wrote. So this one is, yeah, Joshua had another question is, please post this code and the rationale of your Python thinking. Please tell us where it is posted. So once again, we will post these on the discussion forum, the code itself. So watch out for that either tonight or tomorrow, and you could actually go ahead and go through the code and actually try to code it line by line the way that Annie did, so you can actually really think the way that Annie did. So Annie, do you have any?
I mean, that style of thinking takes practice too.
Yeah.
I remember I first saw this in a Udacity class called Design of Computer Programs with an expert programmer named Peter Norvig, and it blew my mind that he was thinking this way, but I loved the way of thinking. And I loved it enough to stick with trying it out, but it was hard at first to write code for functions that didn't exist. But with practice, you'll get it.
Yeah, so this is a great way to just think ahead and like structure
and avoid
thinking.
details. Make sure that your big picture solution makes sense before you spend all this time and energy writing the detailed solutions.
Okay, great. Let's select this question. Is it true I can use Sublime 2 to write Python code? Sorry if you've already explained it.
Yeah, it's absolutely true. Can I share screen?
Go ahead. You are screen sharing.
All right, so let's do a new file with Sublime Text. So I did File, New File. So right now, I'll pull it over here. Okay. If you look up on this tab, you just see Untitled. So the first thing you need to do, so that I can actually code in Python, is save this file as, I'm going to save it on my desktop as example code. But that name doesn't matter. What matters is what's called the extension. So I saved it as example code.py. And that tells any program that knows about Python, hey, this is a Python file. Treat it like a Python file. And now when I write something like def, it becomes blue. Def my function. And now my function is green. And the arguments are going to be orange, I guess. This is really nice, this syntax highlighting, and it's something that you get because Sublime understands that this is Python. If you want to run this code, you can go to project, or sorry, what is it? Tools. It's actually build, and I didn't call my function.
Return.
I didn't even call it.
Oh, you didn't actually call it. Yeah.
This function doesn't do anything with its inputs. It's a pretty terrible function, but that's okay. And sure enough, there's hello. Shows up in the bottom. So you can totally do that, and that's a good way to code. If you're struggling with using, this is a better place to code than in the Udacity window that I showed you earlier. But the Udacity window is good for short little functions, but this is nicer because the syntax highlighting is a little better and a few other reasons.
Great. Thanks for the question, Joshua. Roberta had more of a comment, and it's a very valid comment. I've been watching it from the beginning, but I'm afraid I'm lost. This is getting way more complex than the subject to content. Fun to watch, though.
Well, I'm glad it was fun to watch at least. Honestly, I should have put more thought into the choice of example, I think. The Sudoku one got pretty complicated pretty quick. I think if you're going to take away anything from this, it was writing this function.
So you're screen sharing again, Andy?
Oh, yeah. It was that I wrote this function, check Sudoku, before I wrote these functions. I said, I don't know what check rows is going to look like. I don't know how I'm going to write check columns, and I don't know how I'm going to write check squares. But I know that if it passes all these tests, if my Sudoku grid passes check rows, and it passes check columns, and it passes check squares, I want to return true.
And that's basically the whole program.
Mm-hmm. Yeah. And I should have said otherwise, return false, but that to me was the big takeaway here. When you have a really big problem, try and chop it up into the biggest pieces you can at first, and then for each of those pieces, chop them up as big as you can, and keep doing that, and eventually you'll get down to something where you don't need to chop it up anymore, where you just sort of write a single function, or you flesh out a single function, and you're good to go.
Yeah. So Roberta, if we're gonna be posting this code, and once you're free, feel free to go through this code, and if you have any questions on this particular code, post it up on the discussion forum, and we'll be more than happy to help you walk through the code as well. I think the last question today will be from Matt. I'm not.
Oh yeah.
Yeah. Are you familiar with BB Edit?
I'm not. So Matt, your question is Sublime Text versus BB Edit.
Yeah.
I assume BBEdit is a text editor.
Yeah.
I honestly don't know. Assuming it supports Python and it's got the features you need, you should use whatever text editor you like. I really like Sublime. That's what I started using when I learned to code, and so it's just easy for me to continue using that. But yeah, use whatever tools you want.
Yeah, so I'll just preface that like Sublime is very good. A lot of people in the office uses it. Other people also use other text editors like Notepad++. That's actually a decent one. Another one would be, I think,
Eclipse.
Eclipse. Eclipse is more heavy duty.
Okay.
More heavy duty. Just simple text editors would like add on more brackets.
Oh yeah.
Things like that. So like you can actually just really just look up on the internet and basically just type in like top 5 text editors for Python, and
yeah, you get a lot.
You could get a lot of articles, research, and yeah.
If you don't have any, if you're wondering what this conversation is all about, use Sublime for now. If you don't have any preference, if you never used a programming environment, it's going to be easier to just use Sublime because that's what we're going to be using throughout the course. So it'll just look more familiar and be a little easier. So
yeah,
stick with that.
Okay. Great. So we're at 4:46. So office hours are ending. Our live session has ended. Andy, do you have any final thoughts for our students?
No. I hope you enjoyed this, and remember, if you didn't take away anything else, you can break big things into smaller pieces, even if you haven't solved those smaller pieces yet.
Great. All right, people. If you have any further questions for follow-ups, post in the discussion forums. It's there for you to reach out to us, Andy and I, as well as your fellow students. All right, so next week we'll have another office hour session, and same time, same day, and we hope to see you next week.
Bye.
Bye, everyone.